going to start with your further numerical, that is question number 26. Okay. Okay. So starting with your question. Oh, sorry. Okay, last lecture actually we missed something. Instead of 25, I solved question number 26. So first let's discuss about question number 25 and then we'll jump on question number 27. Okay. Now see exactly when I'm talking about question number 25, what they have stated over here. A light ray enters through a right angle prism at a point P. This is your prism as shown in the diagram. Okay. And they have mentioned that this angle is 90 degrees. Now, this is your incident ray over here. This is the normal. Okay. Further, they have mentioned, as shown in the figure, it travels through the prism parallel to its base BC. So this is A, this is B, and this is C, and it travels parallel. Okay. Now, travels through BC and emerges along the face AC. Means this is your refracted line. Okay, so this is your incident ray and this becomes the refracted ray. Clear? Okay. Now exactly on this basis they are asking you the refractive index mu, it is equals to how much? Now exactly see, when I'm talking about mu, we know that mu is basically nothing but sine I upon sine R. So this is your standard equation. So either I can go with this angle, that is sine I upon sine R1, or I can plot this 90 degree. This becomes your emergent angle and this becomes C. So either you can write sine I upon sine R1, or you can go with sine E upon sine C. Clear? Okay, one of them, anyone is applicable, whatever you are feasible with. Now, in the given question, they have given you the value of I, that is 30 degrees. And obviously, as per the diagram, I can say that E is 90 degrees. So, in both the scenarios, I know only one angle. Either I know I or either I know C. Okay, R1 and C both are unknown. Now, if you remember the property, do you remember that the refracting angle, that is R1 plus R2, is equals to the angle of prism? Matlab over here, can I say R1 plus C, it is equals to A. Okay, or R1 plus C is equals to 90 degrees. So technically, I can go with that R1 is equals to 90 minus C. Clear everyone? Okay. Now see over here, I can write sine C is equals to 1 upon mu. Sine E is 90 degrees, sine 90 is 1. So simple, you can go with this. Okay. Or suppose if you're trying to plot a right angle triangle over here, that this becomes your right angle triangle. Okay, let's say this is your angle C. So what is sine? Opposite upon hypotenuse. So this becomes 1, this becomes mu. This side becomes mu square minus 1. Okay, clear everyone? Okay, so on this basis, can I also write cos C is nothing but square root of mu square minus 1 upon mu. Is that okay? Clear everyone? Okay. Now let's come to the point. So basically we know that mu is nothing but sine I upon sine R. Okay. So technically sine 30 is equals to mu into sine R1. Okay. Or I can write half is equals to mu into sine of 90 minus C. What is 90 minus C? It is cos C. So this becomes mu into cos C. And what is cos C? This value. So this becomes 1 by 2 is equals to mu into square root of mu square minus 1 upon mu. Now this mu gets cancelled and you get mu square minus 1 is equals to half, or mu square minus 1 is equals to 1 by 4, or mu square, it is equals to, I'll shift this over there, that becomes 5 by 4, and mu is equals to 5 by 4, and mu is equals to root of 5 by 2. So this is your answer. Clear? Okay, that is option number 2. So option 2. Okay. Now moving on to the next question, that is question number 27. Okay, question number 27. The quantities which have the same dimensions as that of solid angles are. Okay, so first of all, when I'm talking about solid angle, okay, solid angle is a supplementary quantity, means it has a unit of steradian, but its dimensions are L0, M0, T0. So I need a quantity which is dimensionless. So the first one is strain and angle. Okay, now see, when I'm talking about strain, what is strain? Strain is nothing but the ratio of change in length to the original length. It means it is unitless. Hence, the dimension becomes L0, M0, T0. That's it. Okay, now if you'll see the further quantities, that is stress, strain and arc, angular speed. So all these, they have some of the other dimensions. This example, stress has a unit of Newton per meter square. Okay, if you're talking about strain and arc is a length. So technically it has a dimension. Okay, angular speed omega, it is given as radian per second. So it has a dimension of L0, M0, T minus 1. So your option over here will be option A. Clear? Okay, now moving on to the next question, that is question number 28. Now see, in question number 28, what they have mentioned is that an unpolarized light beam strikes a glass surface at Brewster's angle. Now before going on that, do you remember what is exactly a Brewster's angle? Brewster basically states that whenever you are trying to observe any ray of light which is getting refracted, so technically a ray of light is partially getting refracted and partially it is getting reflected. Okay, so if I'm incidenting a light on any glass surface, so suppose this is your surface. Okay, now imagine this as your normal over here, that this is the normal. Okay, on that basis, if a light is passing through some angle over here, okay, so this will be divided into two parts. One is the refracted one. Okay, and the other one will be the reflected one. Clear? Okay, now on this basis, what Brewster stated that at a certain angle of incident ray, this reflected ray is completely polarized, and that angle is called as Brewster's angle or angle of polarization. Okay, so based on that, if you want to see what exactly the reflected light will be partially polarized, the reflected light will be completely polarized, both reflected and refracted light will be completely polarized. The reflected light will be completely polarized, but refracted light will be partially polarized. So see, we know that reflected ray will be completely polarized. So on that basis, you can mark your option either as second one or the fourth one. Now let's talk about the refracted one. The refracted does not get completely polarized, but slightly it might get a few quantity is polarized. So technically, reflected is completely polarized, whereas refracted is partially polarized. Clear, everyone? Okay. Now moving on to your next question, that is question number 29. Okay, now see, if you want to observe this question number 29, what they have stated over here, the moment of inertia of a thin rod about an axis passing through its midpoint and perpendicular to its rod is 2400 grams per centimeter square. The length of the 400 gram rod is. So the equation is very simple. Okay, the moment of inertia of a thin rod axis is passing through the center. So we have that formula, I is equals to ml square by 12. That's it. So on that basis, I is given as 2400, m is given as 400. It is L square by 12. 400 ones are 400 6 are. This jumps over here. L square becomes 6 12s are 72. So this is L square, or you can say L is root of 72 centimeter. Now let's talk about the option 8.5, 17.5, 20.7 and 72. Now see exactly root 72. So I can go with this, that I know that root of 64 is 8. Okay, root of 81 is 9. So obviously your answer will be between 8 and 9. So there's only one option, that is 8.5. That's it. Okay, so we don't have to calculate the exact value also. Okay. Now moving on to the next question, that is question number 30. Okay, question number 30, what they have stated over here. A thin flat circular disc of radius 4.5 centimeters, that is radius is 4.5 centimeter, is placed gently over the surface of water. If surface tension of water is 0.07, that is the surface tension is 0.07 Newton per meter, then the excess force required to take it away from the surface. In short, we have that formula T is equals to F upon L, where L is the wetted perimeter. L is basically denoted as the wetted perimeter. Now exactly see, when I'm talking about L, so for a disk, the wetted perimeter will be the circumference. So on that basis, can I write the equation as T is equals to F upon 2 pi R, or F is equals to T into 2 pi R. So T is 0.07 into 2 into 22 by 7 into R is 4.5 centimeter. That is 4.5 into 10 raised to minus 2. Okay. So on this basis, if you'll try to solve this equation, 7 ones are, this becomes 0.01. Okay, 22 into 2, that is 44. So this becomes 44 into 4.5 into 10 raised to minus 4. Up 44 into 4.5, approximately that would be around 200 approx, not exact. So I can go with 200 into 10 raised to minus 4 Newton, or 2 into 10 raised to minus 2 Newton. Now let's check about the option. We have 19.8 millinewton. Okay, 1.98. They are talking about the exact value. So exact value, I can go with this 20 into 10 raised to minus 3 Newton, or 20 millinewton. So approximately or exact answer will be 19.8 millinewton. Now see, exactly, whenever you're doing the calculations, don't go for the exact answer, because most probably the options are in that way. Okay, so you can map the approx values. Okay, you can go with the approx values and then identify the correct answer. Okay. Now moving on to the next question, that is question number 31, that is thermodynamics. Okay. Now see, in question number 31, what they have stated, a thermodynamic system is taken through the cycle A, B, C, D, A. So they have given you a PV graph, I think, yes. Okay, so this is your pressure volume graph. This is pressure, this is volume. Okay, and this is your state. Now this point is A, B, C, D. And they have mentioned A, B, C, D, A. Now this value is given as 100 kPa. This value is given as 300 kPa. Okay, this is 100 centimeter square, and this one is 400 centimeter square. Okay. Now, what they are saying, the work done by the gas along BC. So see, if I'm talking about BC, so first of all, when you're trying to observe this BC line, okay, in this line, the volume remains constant now. So over here, can I say that change in volume is 0? And obviously work done is integration of PdV. So if delta V is 0, then work done is how much? That's it. Okay. Now moving on to the next question, that is question number 32. Now see, question number 32. A wheel of bullock cart is rolling on a level road as shown in the figure. If its linear speed is V in the direction shown, which one of the following option is correct? P and Q are any highest and lowest points on the wheel respectively. Point P moves slower than Q. Point P moves faster than Q. Point P and Q moves with equal speed. Point P has a 0 speed. Okay, now moving on to this. If you'll remember the rolling equation. See, in rolling, what happens? Okay, if this is your surface. So this point of contact is basically called as ICR, that is instantaneous center of rotation, ICR. Now what happens now in rolling motion, that your all the body or the entire body tries to rotate around that ICR. Okay, so on that basis, for example, if the center has a speed of V and this is your radius R, so omega will be V by R. Okay, now obviously this point will also have the same angular speed. Okay, but its linear speed will be different. So what I can do is that Vp will be nothing but omega into 2r. Now how come 2r? So from ICR the distance becomes 2r. So Vp is nothing but V by R into 2r. This R and R gets cancelled, that becomes 2V. So Vp has a speed of 2V, whereas Vq is the ICR, so its speed is 0. So on that basis, your answer will be point P moves faster than Q. Okay. Now moving on to the next question, that is question number 33. Okay. Now see, question number 33, the mass of a planet is 1/10 that of the Earth and its diameter is half of that of the Earth. The acceleration due to gravity on that planet is. So simple, they are talking about the relation. So we know that G is given as capital G, capital M upon R square. Let's say for that planet G dash, so G M dash upon R dash the whole square. Okay. Now G dash upon G is equals to Gm dash upon R dash the whole square upon Gm by R square. This G gets cancelled. Okay, now what they have stated, the mass of the planet is 1/10. So technically, instead of M dash, I can write M by 10 into 1 upon M into. Okay, the R square will jump over here and the radius is half that of the Earth. Matlab R dash is R by 2. So can I write it like this? 2 by R the whole square. So this gets cancelled, this gets cancelled. Your equation will be 4 by 10. Okay, so G dash is equals to G into 0.4, that is 9.8 into 0.4, that is 3.92 meter per second square. Understood? So this is your equation. Now moving on to the next question, just a second, everyone. Now moving on to the next question, that is question number 34. Now see, in question number 34, the numerical is very simple. It's about capacitors. Now when I'm talking about the capacitor, the circuit is like this, that over here we have one capacitor, over here we have the other capacitor. This goes on like this. Okay, this becomes the third capacitor, this is the fourth one. Okay, this is the fifth one, and the circuit is complete. This is A, this is B. Okay, 2, 2, 2, 2, 2. All the values are in microfarad. Now it's similar to a Wheatstone's network. Now what happens in Wheatstone's network? In Wheatstone's network, this capacitor becomes null because there no charge will flow through it. So technically, the actual diagram will be like this, that you have two capacitors on the top, you have two capacitors on the bottom, and this is how they will be connected. This point becomes A, this point becomes B, this is 2, this is 2, this is 2, this is 2. Now it will simplify, these two are in series. So series, the equation is 1 upon C1 plus 1 upon C2, or you can go with, okay, they are in series, so C by N. So technically the total becomes 1 microfarad. This total also becomes 1 microfarad. Now these two are in parallel. So 1 plus 1, the total answer becomes 2 microfarad. So is there any option for 2? Yes, the first one. So that is your answer. Simple. Okay. Now moving on to the next question, that is question number 35. Okay. Now see, in 35, a thin spherical shell is charged by some source. The potential difference between point C and P as shown in the figure is. So whenever I'm talking about a thin shell, the property of a thin shell is the potential inside the shell remains constant. So potential at P will be KQ by R, potential at C will be KQ by R. They both have the same potential, so potential difference will be 0. Simple. Okay. Now moving on to the section B, that is question number 36. Okay, section B, what they have stated, the velocity time graph of the motion of a body is shown. The acceleration time graph will be. Now see, when I'm talking about the velocity time graph over here, okay, so the velocity time graph is somewhat like this. Sorry. Over here the velocity is increasing, over here the velocity is constant, over here the velocity is decreasing. Now when the velocity is increasing, the acceleration will be positive. Now in this section, obviously the velocity is constant. So, the velocity is constant. So the acceleration will be 0. Now where the velocity is decreasing, so acceleration will be negative. So this will be your actual graph. Okay, now if you'll see option number 3. Okay. Now moving on to the next question, that is question number 37. Now see, in question number 37, what they have stated over here, if the mass of a bob of a simple pendulum is increased to thrice to its original mass and its length is made a half its original length, then the new time period of oscillation is x by 2 times its original time period. Then the value of x is. Now see, the time period, the formula is T is equals to 2 pi root of L by G. So technically it is independent of mass. You make the mass twice, thrice, 4 times, 100 times, whatever you change the mass. Okay, it won't affect the time period. Okay, whereas if you talk about the length, so time period is directly proportional to square root of length. What they have said that its length is made half of its original value. The length becomes half. Now, if the length becomes half, it means that T2 by T1 will be root of L2 by L1, and that becomes 1 upon 2, or T2 will be T times of 1 upon root 2. But you need the answer in terms of X. So what I can do is that, okay, denominator we need 2. So I can divide by 2, and to balance that multiply by 2. This becomes root 2 by 2. And this is equivalent to that x by 2. So x is root 2. That's it. Now moving on to the next question, that is question number 38. A 10 microfarad capacitor is connected to a 210 volt 50 hertz source as shown in the figure. The peak current in the circuit is. Now see, I want to calculate peak current, but the maximum current. So can I go with this that your I naught will be nothing but root 2 I RMS. Okay, so in short, if you can find IRMS, you can find the peak value. Now, how to find IRMS? So we can go with this root 2 V RMS. V is equals to IR, so I is equals to V by R upon resistance. But it's a capacitor. So technically this will be root 2 V RMS upon XC. Now we know that XC is nothing but 1 upon omega C. So on that basis, if you try to calculate the value of XC, it becomes 1 upon omega will be 2 pi. They have given you the frequency 50 hertz. So 1 upon 2 pi into n into c, that is 1 upon 2 pi into 50 into c is how much? 10 microfarad. Okay, matlab 10 into 10 raised to minus 6. Now 2 into 50 becomes 100, 100 into 10, that becomes 1000, 10 raised to minus 6, and 1000, 10 raised to minus 3. This will jump over here. This becomes 1000 upon pi. Okay, this is xc ka value. Now, moving on to the further step, that is I naught is equals to root 2. Okay, VRMS they have given in the question, that is 210 upon 1000 pi. This can be written as root 2 into 210 upon 1000 into pi. Clear? 0, 0 gets cancelled. Okay, now this pi can be written as 22 by 7. So root 2 into 21 upon 100 into 22 by 7. 7 ones are 7 threes are. So 3 into 22, that is 66. This becomes 1.414 into 66 upon 100. Clear, everyone? Okay. Now, if you'll try to calculate this, this is approximately 90 something. Okay, upon 100, that is 0.9. Now we have options 0.58, 0.93, 0.35, and 1.2. So obviously the closest answer is 0.93 ampere. Clear? Okay. Now moving on to the next question, that is question number 39. Just give me a sec, huh? Okay. So question number 39. In the question number 39, what they have mentioned is that the following graph represents the TV curve, matlab temperature volume curve of an ideal gas where T is the temperature and V is the volume at three pressures P1, P2, and P3 compared with those of Charles' law represented as dotted lines. The correct relation is. Okay. Now see exactly if we'll try to identify the question. Okay, P1, P2, and P. Now let's talk about this. Okay, if you want to calculate that relation between the pressure. So if you remember Charles' law, what Charles' law states that volume is directly proportional to temperature at constant pressure. Okay, now we know that PV is equals to nRT, or P is equals to nRT by P, where nR is constant. So P is nothing but T by P. Or in simple words, can you say pressure is the slope of temperature volume graph? So the quantity whose slope is maximum will have maximum pressure. Clear? Okay, so if you'll observe in the graph, okay, obviously the first one, P1, has the maximum slope. So I can go with P1 is greater than P2 is greater than P3. And this is your relation. So which option? Option number 4. P1 is greater than P2 is greater than P3. Okay. Now moving on to the next question, that is question number 40. Now see, when I'm talking about question number 40, what they have mentioned over here, an iron bar of length L has a magnetic moment M. It is bent at the middle of its length such that the two arms makes an angle of 60 degrees with each other. The magnetic moment of this new magnet is. It means that in the question what they have mentioned, that this is your bar. Let's say this total length is L. Okay, now what they have done, they have broken this magnet into two parts from the middle such that the two arms makes an angle of 60 degrees. So technically, this is your one bar magnet. Okay, this is your another bar magnet. This is L by 2 and this one's L by 2. And this total angle is 60 degrees. Okay. Now what they are asking, calculate, okay, what we have to find? The magnetic moment of this new magnet. So see exactly when I'm talking about this. Okay, this becomes your 1 point. This becomes your second. And this is the actual length between them. See, to solve this, we have two options. First, what I can do is that I can find the magnetic moment of this rod, then I can find the magnetic moment of this rod, then I can do the vector addition, and from that I can get the final answer. That is your one approach. Let's talk about the simplest approach. So see, we know that the formula is small m into 2L. That's it. Okay, so if I have the value of 2L, 2L means over here that is delta L. So can I calculate the magnetic moment? So if I'm talking about delta L, do you remember we have that formula whenever you're trying to difference, matlab if R bar is P bar minus Q bar and P bar and Q bar are equal in magnitude, then R bar can simply be written as 2P sine of theta by 2. So we have that equation. So similarly, if I go with this, I can write 2 L by 2 sine of theta by 2. Now theta is 60 degrees, sine 60 by 2, that is sine 30. So this becomes 2L by 2 into sine 30. Now sine 30 and 2 gets cancelled and your delta L is L by 2. So capital M is small m into L by 2. That is equals to, now what was your initial? Let's talk this, let's say this is M dash. So your initial momentum was m into L. Now it is m by L, sorry, ml by 2. So m dash is m by 2. So this becomes your answer. M by 2, which option? The second one. Okay. Now moving on to the next question, that is question number 41. Okay. Now see, when I'm talking about the question number 41, what they have mentioned over here, the minimum energy required to launch a satellite of mass m from the surface of the earth of mass m and radius r in a circular orbit at an altitude of 2r from the surface of the earth is. Okay, the minimum energy required. So I have to calculate the minimum energy, or in short, the kinetic energy over here. Clear? Okay, now see, we know that whenever you're trying to eject any object, okay, what they have mentioned, the minimum energy required, okay, to launch a satellite of mass m from the surface of the earth and radius r in a circular orbit at an altitude of 2r. So we know that at that point, the velocity will be square root of capital G, capital M, R plus H. So that becomes Gm by 3r. So this is your velocity needed. Okay, now obviously, if you want to launch, you need kinetic energy. So can I go with by laws of conservation of energy? Energy on the total energy on the surface is equals to total energy on the height. That is potential energy on the surface, kinetic energy on the surface is equals to potential energy at that height plus kinetic energy at that height. So obviously this becomes minus of capital G, capital M, small m by r plus kinetic energy on the surface is equals to minus of capital G, capital M, small m upon r plus h plus half m v square. Now, obviously, using this relation, I can go with this minus of capital G, capital M, small m by r plus kinetic energy is minus of capital G, capital M, small m upon 3r plus half small m, capital G, capital M upon 3r. Okay, now if we'll solve this, This becomes 6. LCM, if I take the LCM, that will be 2 over here. Okay, and your final answer is 5 by 6, capital G, capital M, small m by R. So this becomes your equation. Again, which option? Option number 1. So that will be your correct answer. Okay. Now moving on to the next question, that is question number 42. Now see, when I'm talking about question number 42, what they have stated over here, a parallel plate capacitor is charged by connecting it to a battery through a resistor. If I is the current in the circuit, then in the gap between the plate, obviously, see, this is the concept of displacement current. Okay, so if you see that chapter electromagnetic wave, it has been proved that the convection current and the displacement current has the same value. Okay, the convection current and the displacement current has the same value. Now what happens whenever there is a wire, okay, over there will be the convection current, and whenever, if you'll see that there is a gap, okay, over here we'll be having the displacement current. Again, over here we'll be having the convection current. Okay, so there is no current, obviously there is current. The displacement current of magnitude equals to I flows in the same direction as I. Obviously, that is the concept, that your convection and the displacement current should be equal. Displacement current of magnitude equals to I flows in the not opposite direction, in the same direction. Displacement current greater magnitude, no, it is always equal and in the same direction. So on that basis, your answer becomes option number 2. Clear, everyone? Okay. Now moving on to the next question, that is question number 43. Now, what is 43? The property which is not of an electromagnetic wave traveling in a free space is that they are transverse in nature. Obviously, they are transverse in nature. The energy density is equals to energy density of magnetic field. Obviously, the electric field and magnetic field energy densities are equal. They travel with the speed of, this is the formula. Okay, C is equals to 1 upon root of mu naught epsilon naught. They originate from charges moving with uniform speed. No, the statement is electromagnetic wave can only be produced by accelerated charges. That's our statement. Okay, so obviously the answer is option number 4. Now moving on to the next question, that is question number 44. Now see, when I'm talking about question number 44, what they are, just a second. Sorry. Okay. Now moving on to the question number 44, what they have mentioned in question number 44. Okay, a metallic bar of Young's modulus 0.5 into 10 raised to 11. So the value of Young's modulus is given. Coefficient of linear expansion is there. Length is there. Area is there. Heated without expansion or bending, the compressive forces. So we have that formula now. Stress is equals to y alpha delta T. Or we can go with force is equals to YA alpha delta T directly. We have that equation. So using that, Y is 0.5 into 10 raised to 11. The area is given as 10 raised to minus 3 meters square. The coefficient of linear expansion is 10 raised to minus 5. And the change in temperature is 100. Okay, now if you solve this, you will get the answer to C. 10 raised to minus 5, 10 raised to minus 3, that becomes 10 raised to minus 8. This 10 raised to 11 and 8, that becomes 10 raised to 3. 0.5 into 100, that is 50. So 50 into 10 raised to 3. What are the options? 5 into 10 raised to 3, 50 into 10 raised to 3. So obviously the option is second one. That is your answer. Clear? Okay, now moving on to the next question, that is question number 45. Now see, in question number 45, what they have mentioned, choose the correct circuit which can achieve the bridge balance. Now before going on that, see, whenever I'm talking about the Wheatstone's network, so let's say, okay, this is your Wheatstone's network. Okay, this is P, this is Q, this is R, this is S, and over here, this is the galvanometer. Now see, let's make the formula pretty simple. So what I can do is that the ratio of this side should be equals to the ratio of this side. It means that P by Q should be equals to R by S. Sorted? Okay. Now moving on to that, the first option A, first one, 10 by 15, 10 by 5. So 10 by 15 and 10 by 5. Obviously, they are not equal. Second option, 10 by 15, 10 by, okay. Second option is also the same, or what? 10 by 15, 10 by 5. Acha, they have added a, oh, kya bolte? What's that? Oops, sorry, I missed it. Okay, they have added a diode also. My mistake. I apologize for that. Okay. Now see exactly, they have added a diode and they have mentioned that diode has a resistance of, okay, just a sec, 10, 10, 15, and D is the diode, D is the diode, D is the diode. Okay. Okay, they have not mentioned the value of diode. Okay, not an issue. Okay, so see, we can go with this. Okay, so if you want to solve this, this can be written as 10 by 15, the first part. The other will be 10 by 5 plus resistance of the diode. Okay, now moving on to the second one. In the second one, if you'll try to observe, what they have done is that, okay, what they have done is that the diode is applied in the reverse bias in the second one. So obviously, if the diode is in reverse bias, the circuit is not working, so ignore that. Okay, the second, obviously not possible. Third one, okay, 10 by 15 on one side. And on the other side, it is 10 upon the diode and the 5 ohm are in parallel. So obviously, whenever you're trying to apply a circuit in parallel, the resistance cannot be increased. In fact, it will decrease. So obviously, this total value will always be less than 5. So obviously, this is not possible. Let's talk about the fourth one. In the fourth one, what they have done is that, again, now see, they have reversed the batteries, the polarities of the batteries. So on that basis, this is 10 by 15, no doubt on that. But in this fourth one also, the diode will be in reverse bias. Because of that, it cannot be a Wheatstone's network. So obviously, you are left with this. This becomes your answer. Now see, they have not given you the value of diode, so we can assume that diode can have any resistance depending on the parameters. So it might have a resistance of 10. So technically, it is equal. The other three options can be ignored or can be simply 0. Okay. Now moving on to the next question, that is question number 46. Okay. Now see, when I'm talking about question number 46, what they have mentioned, a sheet is placed on a horizontal surface in front of a strong magnetic force, magnetic pole. A force is needed to, okay, hold the sheet, okay, there if it is magnetic, hold the sheet there if it is non-magnetic, okay, move the sheet away from the pole with uniform velocity if it is conducting, move the sheet away from the pole with uniform velocity if it is both non-conducting and non-polar. Choose the correct statement. Okay, so see, first of all, obviously if the sheet is magnetic, I'll have to hold it or else it will get attracted. If it is non-magnetic, it does not make any difference. You hold it or do not hold it, it won't affect the sheet. So obviously the statement A is correct. Statement B is wrong. Now let's talk about statement C. Move the sheet away from the pole with uniform velocity if it is conducting. Okay, so that becomes the concept of electromagnetic induction. Okay. Now, obviously, so if this says that your statement C, that is also correct. Okay, and the last D. Obviously, see, if it is non-conducting, then no use. You move the sheet or do not move the sheet, it does not makes any difference. So both is wrong. So your answer is A and C. That is option B. Okay, now moving on to the next question. That is question number 47. Now, what is question number 47? 47 is, if the plates of a parallel plate capacitor connected to a battery are moved close to each other, then see, if we have a parallel plate capacitor, okay, and on that basis, what they are saying, if they are moved close to each other, okay, the charge stored in it increases, the energy stored in it decreases. Okay, so I have to check which of the options are correct. Okay, its capacitance increases. Now see, when I'm talking about capacitance, what is the formula for capacitance? C is equals to A epsilon naught by D. So C is inversely proportional to D. So if you're decreasing the distance, that means you're moving closer to the you're moving close to each other. So D is decreasing. So obviously the capacitance will increase. So on that basis, I can say that my statement C is correct. Now statement C is only in one option. That is the second one. Okay. So we don't have to find the other ones. Okay. It's simple that obviously statement C is only in one option. There's no other option. Yes. So that is your answer. That is option B. But still, let's clarify the other statements also. Okay, the charge stored in it increases. Now see, C is equals to Q by V. Now the potential is constant now. So if C is increasing, it means Q is also increasing. So statement A is also correct. Okay. Now the product of charge and velocity increases. So obviously, see, potential is constant, charge is increasing. So hence their product increases. That's it. So obviously, if I'll go with that, or a statement A, C, and E are correct. Now moving on to the question number 48. Now see, when I'm talking about question number 48, what they have stated over here, two heaters A and B have a power of 1 kilowatt and 2 kilowatt. Those two are first connected in series and then in parallel to a fixed power source. The ratio of the power outputs of these two cases is. Now see what they are saying, that first they are connected in series, then they are connected in parallel. I have to calculate the ratio of power. Now when I'm talking about power, we have that formula, power is equals to V square by R. Okay, so this is your equation. Clear? Okay. Now see, in the question what they have mentioned, that the power of A is 1, the power of B is 2. And they are connected in series. Now see, when they are connected in series, what will happen? That the current will remain constant. Okay, but the potential will be different. Means I can use this formula, power is equals to I square by R. So PA upon PB is equals to RA upon RB. So this says that RA, okay, or 8 minute. PA is how much? PA is 1 kilowatt, PB is 2 kilowatt. Okay, now see, just a sec. First of all, I have to calculate the resistance. Now, so moving on to that, if I want to calculate the resistance, PA upon PB is equals to RB upon RA. Now this is 1 by 2. So obviously RA is twice of RB. Clear everyone? Okay, now when I'm talking about series combination, in series, these two resistance will be added. So your R equivalent becomes 3R. So power is V square by 3R. Okay, now when they are connected in parallel, so this is the condition for series. When they are connected in parallel, R equivalent becomes 2R, okay, by 3. So your power becomes 3 by 2 V square by R. Clear? So this is the series one, this is the parallel one. If I want to take the ratio, PS upon PP, that is equals to 2 by 9. Okay, do we have that option? Yes, we have 1:1, 2 by 9, 1:2, and 2 by 3. So this becomes your final answer. Now the next one, that is question number 49. Now see 49, a small telescope has an objective of focal length of 140 centimeters. So focal length of objective lens is 140 centimeters and eyepiece focal length is 5 centimeters. Okay, the magnification I can simply use the formula m is equals to focal length of objective upon focal length of eyepiece, that is 140 by 5, that is 28. That's it, done. Moving on to the last question, that is question number 50. Now see in 50 what they have said, f is equals to alpha t square plus beta t on a particle at a given time. The factor which is dimensionless if alpha and beta are constants. So which factor is dimensionless if alpha and beta are constants? Now first of all, if I'm talking about this is Newton or it is kg meter per second square is equals to alpha into second square. So alpha becomes kg meter per second raised to 4. Clear? Okay. Now let's talk about beta. So this equation is also equals to beta into second. So beta becomes kg meter per second cube. So if you're trying to take a ratio of alpha and beta, you're still left with 1 second, that is in denominator. So obviously alpha by beta is equals to 1 by second. Now the options are beta t by alpha, that cannot be the answer. Alpha t only, alpha beta into t, that cannot be the answer. If you're multiplying alpha and beta, so obviously that cannot be the answer. So the third and fourth options are already getting eliminated. Now alpha by beta is 1 by second. So if beta t by alpha I'm writing, that becomes second into second, that is second square. So first cannot be the answer. The last is alpha t by beta. Now alpha by beta is 1 by second, t is second, that becomes L0, M0, T0. So your answer is option 2. Clear everyone? Okay. So this is the solution of your NEET question code Q6. Okay, obviously you all have the same questions. The only thing is that the order of the questions might be different. So you can go through your question paper and check what is your answer. Okay, so all the best everyone for your exams. Have a nice day everyone. Okay, bye-bye.